Okay, so yeah, hi everyone. Thanks a lot for coming to this meetup talk, and thanks a lot, firstly, to Nick for hand holding me through the whole thing. What I wanted to talk you through today is getting into the right mindset when adopting stream processing for the first time. So just a quick note for those of you who have never heard about Ververica. I work as a developer advocate at Ververica, and it's the company of the folks who originally created Apache Flink. So every day I get to work with the Carr maintainers of Flink and being involved in this really vibrant open source community. And since the beginning of last year, our company is part of the Alibaba group, who, for those of you who don't know, is also one of the biggest users and contributors to Flink. So the motivation behind this talk leans a lot on my day-to-day work. So very frequently, I'll get messages like this one from random people asking me how they can make the jump from batch to stream processing. And my reaction in the beginning was always a bit not really knowing what to say, because until around 2 years ago, I was very deep in this world of pain and batch and legacy data warehousing technology. And when the opportunity came to work with Flink, I didn't really go through any of the other so-called big data processing tools like MapReduce or Storm or Spark. So I just did this Olympic jump over all of this and landed directly on my face on Flink, which is one of the most advanced stream processing engines to stay. And this kind of got me thinking, how did I in the first place adapt, or how did I manage this transition from a batch first or from batch first environments in the past to streaming? And how could I make sure that when I get these kind of questions, I give the best possible advice to people? One of the first things that people usually ask me is, so should I learn Scala or should I learn Java? And this might actually be the hardest way to start. So what I wanted to focus on is a more bottom-up or a more structured approach to learning stream processing if you're coming from a different or a more conservative background like me. Because before learning anything else or anything new, you kind of also need to unlearn a lot of the assumptions that you start with. So in the end, there's a very fundamental shift that first needs to happen in your brain. So there's, when people first think about streaming, it's very common and intuitive that they first think about data analytics. So not that long ago, this is what analytics used to look like. And this is the kind of environment I used to work in. So you had a bunch of transactional databases, maybe some static sources of data. You would run some ETL processes to integrate everything, combine all the data into something useful for business. And then you would store this away in a data warehouse in nicely structured tables that served some business purpose. So your quest to data will look something like this. You would run very long nightly jobs, and after some hours, you would have your results. But in reality, what would happen is that these nightly jobs would likely fail because, for example, your processes ran out of memory. Then someone had to wake up, fix the problem, rerun the jobs. Probably your stakeholders at this point are already complaining that their data is late. And then finally you would get the results. But in the end, if you look at it, this doesn't make a lot of sense because most of your source data is continuously produced. So it doesn't make sense that someone is waiting for yesterday's data. And most of the logic that you use to run these processes doesn't really change. In the end, what changes is your data. So something we can't really escape is this concept that everything is a stream nowadays. So if you were used to looking at things this way, your batch data is now a bunch of events that are continuously produced and that should be continuously processed. So you have a set of event sources that can be anything from connected devices and vehicles to web clicks, financial transactions, and so on. And all of them are producing events that end up in some sort of centralized distributed log, something like Kafka or something like Pulsar. And then you might want to run a set of transformations on top of these events, like filtering out some garbage or just correlating events, joining them, doing aggregations over time, maybe persisting some intermediate results to long-term storage like HDFS or S3, and then publishing our output to somewhere to some sink. And in the end, the time that it takes from data to go from your event sources to your sinks, it might be more or less critical depending on your use case. But you certainly don't have to wait a full day or more because the value of your data is deteriorating the more time it passes. So if you come from a batch first environment, the first important thing to absorb is this really core difference between batch and stream processing. So between processing data, static data that is at rest versus processing data that is continuously being produced. And then also understanding the kind of use cases that fall under the spectrum between these two. So things that tend more to be covered by batch processing or by more lag time applications, and things that tend more to real time, near real time, or in some cases hard real time, even though this is kind of rare. So to give you more of a sense of what these use cases look in the real world, I put here in the slide some production users of Flink that are using stream processing to build core infrastructure like large scale data pipelines. Netflix is processing, I think, 3 billion events per day with Flink. Machine learning based fraud detection engines or log analysis for service monitoring and anomaly detection. And then other users are using stream processing with Flink for more domain-specific use cases in analytics and in machine learning, like Weibo is building unified pipelines for online and offline model training. Uber is allowing their internal data users to independently build end-to-end streaming analytics pipelines just using SQL. And Criteo built their internal feature generation platform also based on Flink. So this is the first step, really taking the time to understand or to get your foundations about what stream processing is and what it can be used for. And once you got this crossed out, then one thing that helps is to focus on the new concepts that are associated with stream processing and how these relate to maybe existing concepts that you already have from the batch world. And so in this section, I will touch mainly 3 things, because when you're getting started, in stream processors like Flink, there are a lot of moving parts. So it might be very overwhelming that you try to just understand and learn about everything at every level. So I think that the key things that you need to understand if you're new to this way of processing data is really bounded versus unbounded data, event time versus processing time. So the different notions of time that you suddenly have when you are doing streaming, and then also fault tolerance. So like how you can guarantee that whatever you're building can resist some crash and continue processing like nothing happened. So the first point is about the nature of your data. So the first thing that you need to understand here, or a new concept for you, will be the difference between bounded and unbounded data. So when you're dealing with data in batch, the data is, like I said before, at rest, and it already has some hard boundaries defined. So for example, you might want to read 1 day's worth of data, or 1 hour worth of data. And as opposed to that, when you're dealing with streaming, you have an ever-growing stream of flowing events. So your data set is unbounded, and you can look at it like it's just an infinite flux of data flowing through your system that you somehow have to juggle. So if you want to apply any computations to over these events that you are continuously receiving, or for example, join them together or do some aggregation logic, you first need to define what the same, or what this idea of boundaries are over an unbounded data set. Because you only have so much resources, and you're dealing with possibly infinite data. So the way you define these boundaries is in streaming is by using windows, which basically what windowing does is bucket your data into finite size chunks. The second important thing to understand is then these different notions of time that you suddenly have. So the difference between event time and processing time, and how this actually affects the output of your application. So event time is the time when the actual event that you're processing took place in the real world. So the time that is embedded into the records when they are produced, wherever they are produced. So if you want to process your events exactly in the order that they happened in the real world, you should always use event time, because this guarantees that your results are always the same. So your results are deterministic, even when you have out of order or late events, which is really common in streaming. So if you think about, for example, use cases like IoT data processing, this means that even if a sensor is down, or a bunch of sensors are down for some period of time, with event time, you can still process it in the correct time window. And here, what one of the first trade-offs that you need to do is decide on the trade-off that you want to, or how much you want to compromise how complete your results will be, and the latency, or how fast you can produce those results. And on the other end of things, if you only care about speed and you don't really care about how correct your results are, you can just use processing time, which is the time the event was made available in the machine that is processing it. And this is probably one of the things that will have most impact on you, or one of the things that you will have most difficulty adapting to, because in batch, there really is no need to worry about out of order events or late events, because you process all of your data in a single bulk. And the last point is, so the last thing that is really different between when you're doing batch processing or stream processing is that your batch pipelines run on a fixed schedule. So it kind of wakes up, it does some processing, and then goes back to being idle until it's time to resurface, or to when it's scheduled to run again. And in contrast, streaming applications are long running. So this means that they are meant to run forever until you decide to cancel your job, for example, or until something fails. And when something fails, you kind of need, or you kind of want to make sure that your applications are fault tolerant, and that they can survive machine failure, for example, or even sometimes like your application, your whole application manager through something like high availability. So what if the application really goes down? You can't really afford to lose your data, And you kind of want to make sure that you restart processing from the most recent point before everything went to shambles. So the way that this is ensured in Flink, or the way that Flink ensures that all the state or all the data that is involved in your application and your application processing, the way that Flink makes sure that this is fault tolerant is by taking a periodic snapshot of your application state, or and then writing these snapshots to a persistent storage like S3 or HDFS or any other blob store of your cloud provider. So when your application does go down, then Flink automatically recovers your whole application state based on the most recent checkpoint. And then, like I said before, you can continue processing your data stream like nothing happened, and with strong consistency guarantees. And here, again, you have to choose you have to choose what you want to trade off, so that you can have the strongest consistency guarantee. So like if you want to have exactly once consistency guarantees, you kind of need to trade off maybe latency for that. So to round it off, so now that you have got a hang of the streaming mindset, the essential building blocks that make it different to batch processing, and the additional care that you need to take when you're doing streaming, you can more easily just get your hands to work and build your first stream processing pipeline. And here, it really depends on what you're most comfortable with. And I think this is one of the good things about using Flink or using another stream processor in 2021, is that you're no longer forced to actually know Java or to know Scala. Flink as a layered structure that gives you like very different levels of abstraction. And this means that you have a choice depending on, for example, what you're used to from the past. This means that you don't necessarily need to learn a new language to actually use Flink. So at the higher level, you have APIs like SQL, the table API, and PyFlink. They are a bit more closer to a relational way of thinking about data. So for me, as a first-time Flink adopter, I gravitated very naturally to the table API and SQL because, yeah, the kind of abstractions that I find there are very similar to what I used to work with before, and I can even just write pure SQL, pure standard SQL, and then it works on Flink. And as you progress down the API stack, using the API starts getting a bit more challenging, but then you get more and more control over what you're building and how your pipelines are executed. So, and when you reach the core building blocks of Flink, you can really do anything. Flink is really customizable and extendable. And the good thing is that you're not also limited to a single API. You can actually mix and match everything. So for example, if you're using the table API, which is either in Java or Scala, you can throw some SQL in there. Or if you're using the data stream API, which is a lower level API, you can transform your streams into tables at a higher level of abstraction. So it's very, yeah, you have a lot of options here. So how do you get your hands on, or how do you do the last mile of actually building something? My recommendation is that you start with a language or an abstraction that is familiar to you. Like I said, you have a lot of options. You don't need to start with something that makes you feel kind of out of place. And the Flink community has worked on some resources that I'm linking here that can help you start experimenting, getting your hands on. and building your first stream processing application. So starting from the beginning to finish everything off, I went from being dumbfounded when I received this kind of messages from people to actually having a plan now. So what I would say, if you're a person new to streaming and you have some background in batch processing, I would say to take some time to really invest in learning the one-on-one of stream processing, because this will be really important. I think it's really important not to skip steps, because at some point it will bite you in the butt. So then really take the time to understand or to make the relations in your head of how stream processing really differs from batch processing, and that how both of them apply to different use cases. Start with something familiar and then increase complexity gradually. Don't like go all out and trying to use every possible feature and build something really complex. Just take your time and start really simple and with things that you're used to, or maybe that you already know, instead of learning new technologies on top of another new technology. And then ask questions, because one of the great things of working with open source tools, or just working in the open, is that you have a big community that is available to you, and that doesn't really judge if you make whatever, if you want to call it, stupid questions, or because when you're getting started, no question is a stupid question, and the community, at least the Flink community, is very welcoming, and you can always reach out. So I left a link so you can find your way if you need help and you actually get started with Flink. And that was basically it. Thank you.
Amazing. Thank you, Marta. So I'll ask everybody to unmute, if that's okay, and we'll show our appreciation. Thank you, Marta.
I'm glad I was on time.
Sorry, say it again.
I'm glad I was on time. I didn't time myself.
Spot on.
Ever.
So there are a few questions in the chat. I don't know if Andrew, do you want to unmute and ask people to unmute and ask their questions? Do you want to curate?
Certainly. So yeah, has anyone got any questions? Either put it in the chat and I can ask, or you can ask directly. Who's got a question?
I'll jump in. Yeah, really great talk, Marta. I hadn't seen it, so it was yeah, good to see the slides and hear the words. Yeah, I suppose my question is, a lot of companies, as you alluded to, have very large batch stacks already, and like how would you go about getting one of those companies to migrate from that to becoming more stream oriented? You know, what lessons have you learned, or have you seen when you've helped companies go on that journey? Like, what should they, what are the good things to do, and what are the things they should avoid where it all goes wrong?
Yep. So that's a really good question. And yeah, I think that it's always harder if you are trying to adopt this as a big team and not as just someone who is at home trying to improve their skills, because it usually, what I've seen from cases in the community is that it really depends on, or it ends up boiling a lot down to the experience that your team already has. So sometimes you have people who, maybe like me, were very deep down in very ugly and very legacy environments. And so maybe you have part of a team who is who can catch up quicker and can actually maintain also these systems, because that's also, I think, a big difference there. And yeah, so sometimes I feel that there's this kind of conflict, like if you don't have a team that is kind of at the same level of that, if you have like some team members that kind of trail behind on what technologies they've historically used, think sometimes it can be really, really tricky to adopt this as a company. And yeah, I think it's like I said, it's not so much just about choosing a technology and learning a new technology. You actually have to build so many things around streaming. Like you need completely different monitoring, you need completely different mechanisms for fault tolerance. Like I said, like if you need to set high availability and this kind of stuff. Also, the way you deploy things is really different. So yeah, I think, but there are a lot of examples in the Flink community. For example, Netflix has a lot of talks out there about migrating batch pipelines to streaming. So I also took a lot of inspiration from those because yeah, they really touch on all the issues that arise from this transition, yeah, at different levels, technically and team wise.
Yeah, that's a really interesting answer.
Yeah.
Cool, Marta. So I've got a quick question for you, and this is so that you can sell Flink and tell everyone how great it is. Why would you choose Flink over something like Apache Spark? Q sales job for Flink.
Yeah, like we chatted before, this is always very political question, but I think that especially against Spark, what really makes a difference is that Flink was originally built from scratch for streaming, so it was not a batch engine that suddenly also could do streaming. So I think this is an advantage, and this is and you can really see when you go. I mean, you can only go so far with Spark when it comes to latency, right? To low latency, and with Flink, you really have a lot of crazy use cases of hard real time out there, and just also the way that Flink does state management, I think, is really particular and very efficient. And you can see that just by the scale of deployments that people out there achieve with Flink. So if you see, I think the biggest deployment we've ever heard about is Alibaba. They are processing, like in this shopping festival, Double 11, they are processing 4 billion events per second with Flink, and they're holding like 100 terabytes of state in their biggest job, which is pretty crazy. And I think that's the cool thing about Flink is that it can really go to a scale that I don't think any other engine out there can at this point.
So furthering on from Nick's questions, so because Nick's asked about 500 questions in the chat, but confining it down to parts of it, how hard is it to start streaming? So you gave a little bit of a journey, but if I'm a techie and I want to try out streaming, Nick's obviously a bit scared of streaming, as you can see from his questions, but in reality, how hard or easy is it to do? And by the way, I'm going to have to disappear in 2 seconds because one of my children's just causing chaos outside. So I'm going to ask the question, then shoot off, and then come back.
Yeah. So how hard it is, I think it depends on a lot of things, and also it depends a lot on how you get started on it. That was kind of my point here, is that if you just jump right into the weeds of it, yeah, it might get very complex very fast. But if you try to take an approach of starting a bit more maybe on the higher level APIs of Flink, for example, and then you start building down your knowledge into more of the internals, because yeah, at the higher level, there are a lot of things that are abstracted away from you. So a lot of things like performance optimizations that are done for you under the hood. And for example, like state management, if you're using Flink SQL, is something that you don't really get hit in the face directly. So the more you start looking for customizations and optimizations yourself, I think it can get quite complex. But I think that the trick is just really to find what you're comfortable with in terms of language, and then yeah, the level of difficulty that you're comfortable about starting with, I think.
And by that, do you mean that it's possible to get into the configuration parameters and the window sizes and all that sort of dirty detail?
That's the thing, you can, but I wouldn't recommend that you start there unless you kind of, because yeah, the thing with Flink is that it has a really, like I said before, a lot of moving parts, and a lot of people also ping me about not knowing where to start. So I think that that's why I try to share here some resources that are kind of that start you off from like level 0 of this is, you build something really simple, and then maybe you have an idea of something that you want to do. So maybe you want to do a custom windowing, and then you go and look for how you can do that. But or then you go and look for how you can do mini batch in SQL so that you have more performance. So, but not from off the bat. I think there are a lot of knobs, so too many knobs and too many configuration. You can just like.
And what tutorials or documentation would you recommend as a starting point? Presumably, you've got the Flink Forward videos from the Flink Summit, and presumably you mentioned there the Netflix videos. There must be a whole host of things for people to consume.
Yeah, definitely. Like use case wise, there's a lot of talks from Flink Forward and other conferences. And there's also a lot of playgrounds. So a lot of the things I share there are just basic walkthroughs, or something we did, me and 2 of my colleagues in December. So we started a Flink SQL cookbook. So it really guides you through like how, from the very basic, like how to create a table until doing pattern matching on streams with SQL. So like I said, I think this is missing a little bit, and it's also on me as a developer advocate to kind of create more of that content, like more guides on how to get started without feeling too lost because there are too many things that you can focus on.
Okay, cool. I think that's good. I think we're going to vamp to the panel. I know that Andrew's just popped out. We'll be back in a second, but maybe I can bring Dan in here. So Danny Cook, who is technical architect and data scientist at Moneyhub. And I just wanted to take one step back as an opening question, and maybe the panel could establish the difference between the messaging and processing sides of streaming. Maybe Dan, you could speak to that.
Yeah, I think Marta put it in. There's a good slide in there that sort of covered this off, and I think it's very easy, isn't it, to get lost in what I term the Hadoop ecosystem, although people aren't too happy about when I say it's the Hadoop ecosystem. When you start throwing around names like Kafka, Spark, Flink, but yeah, for me it boils down into two major components. There's the messaging element, and there's the processing or compute side, if you want to call it processing or compute, and then the technologies fall into either messaging or processing or both of those boxes. I suppose that's where it gets a bit blurred. So Kafka at its heart is a messaging solution, and then in the processing side you've got Spark and Flink for doing those sort of business queries and raising those sort of real-time alerts. But I suppose it gets a little bit blurred because when people talk about Kafka, they're not always talking about the messaging side. They may be talking about KSQL, which is Kafka venturing into the processing space as well. But yeah, I've only named like 3 technologies there, but there's tens more. If I don't think hundreds, but yeah, definitely tens more.
Yeah.
And I guess Kafka has become a bit of a ubiquitous name now in the enterprise.
Yeah, I was going to throw this to Marta actually. So my streaming journey began 9 years ago. It's like I'm starting to feel old now. It's almost a decade from like I built a streaming framework before Storm existed, and then had to bin it because Storm was way better. But over the sort of past decade, I sort of spent 5 years of people not really getting why this stuff was important. But over the sort of past 3 to 4 years, I've seen a lot of companies and enterprises adopt Kafka and really sort of buy into it. Maybe I'm looking at the wrong places, but I've not seen the same uptake of say Flink or Spark yet. And I suppose my question, Marta, is have I just been looking at the wrong places? Or do you think we're not quite there yet, and you know the sort of the big adoption point is still 2 or 3 years to come?
Yeah, I think what you say about Kafka is definitely true. And I think one thing that a lot of people, or that kind of hinders the adoption of Flink, is that you don't really have a self-service or a managed service for Flink. I mean, there is a managed service on AWS, but it was always like it had this very secretive name that no one really knew that it was actually managed Flink. But I think that makes some difference, because at least in our company, we can see some difference now that we have the product that my company builds, Ververica platform, that makes it really easy to deploy Flink on Kubernetes, which, yeah, if you try to deploy vanilla Flink on Kubernetes by yourself, it's actually pretty intense. But we've noticed that, like, by just offering this product that makes it, at least the deployment part, much easier, already a lot more people are adopting Flink. So I think it comes down a lot to deployment options is definitely one of the reasons, because Confluent, they have Confluent Cloud, and they have like a really tightly integrated ecosystem there with Kafka Connect and all these tools that they have. And yeah, Databricks, I think, or Spark, I think, is a bit of a different world, right? I think it's much more, at this point, it's much more focused on analytics and machine learning. So they have their own ecosystem. I think it's a bit different when you look at K-Streams or Flink at this point. There are more, I think Flink and K-Streams are a bit more generic solutions now, and Databricks is a bit more verticalized already, if that makes sense. So yeah, but for Flink, definitely, I think deployment options make a big difference. But yeah, there's also a lot of effort in the community right now to improve that. So now you can Flink natively integrates with Kubernetes. You can get like, you can actually get high availability without Zookeeper, just using Kubernetes high availability. And auto-scaling is coming, so I think that's also a big thing for a lot of users that kind of block them from adopting Flink. So yeah, I think one step at a time. I think the community is kind of moving forward.
So managed services is coming though. It sounds imminent.
What about the sort of big data tag that's attached to Flink and Spark? Do you think that's justified? Do you think, or have you seen people using it out there for use cases that aren't necessarily like terabytes and terabytes, or you know, huge throughput numbers? Has Flink and Spark and this sort of tech got a place in the smaller business? And you know, and what is that place?
Yeah, I don't remember exactly the numbers, but I think I have the slides here somewhere, because there is someone was at our conference once presenting how, okay, I found them, how they actually deployed Flink on a cluster of five Raspberry Pis. And I found that quite cool because they were doing, I think it was traffic data processing or something like that. And yeah, they were just using this little cluster of Raspberry Pis that they call the fridge. And yeah, they managed to get like 800 events per second or something like that on that little setup. So I think you're really seeing a lot of everything, but for sure, I think the bigger chunk of users are like the really big tech companies. So like, I think all the big tech companies you can think of are using Flink to some crazy scale. So like Netflix, Yelp, Alibaba, Pinterest, Lyft, Uber. And so yeah, I think there's a bit in the whole spectrum, but of course that you hear more often about the big users because they just have like these crazy use cases. Yeah.
But Dan, were you driving at the point that it is no longer necessarily, it doesn't have to be a big data offering to go for this kind of technology? Is that...
Yeah, and I think Marta sort of picked up on that a little bit in there, like talking about the sensor use case. Like sensors aren't always associated with sort of huge volumes or huge throughput. In some cases they are. But yeah, I was trying to sort of get to that point of, in my experience, like a lot of companies have a need for a real-time processing. You know, from a business perspective, finding out something's happened now means you can act on it. Like I worked in the past with like cyber threat detection. It's like people breaking into networks, monitoring net flow data, and actually knowing someone is doing something unusual on your network as it's happening and cutting them off there and then. You know, is way more beneficial than giving them a day and then like denying their access the day after they've already taken everything off your network. But yeah, maybe Andrew, I know you've been talking to companies recently about the sort of the benefits of streaming. Yeah, I'd be interested to hear some of your use cases.
Certainly in financial services, processing like trade data, which has typically been batch, where they finish a trading day and then they do the risk calculations. We've seen lots of risk calculations go from overnight processing. In fact, I won't name the asset manager, but there was an asset manager in the US that was doing overnight processing, and it was taking them 33 hours. Now, anyone who's used to the length of the day goes, how do you fit 33 hours processing in 24 hours? So clearly they literally ran out of time and they moved to, I won't mention the name, but it was Apache Spark to do their processing, and they brought it down to 33 minutes. Now, for that, they still wrote it in batch, hilariously, but that was fast enough for them. And I think there's a big move, certainly what I've seen, you know, certainly in financial services, that overnight batch processing has all been moving to streaming. And one big benefit, which, you know, Marta alluded to, is you go from this thing where you get woken up in 2 a.m. because some batch jobs failed, to there being an exception queue, and just the individual cases that don't work get put into the queue, as opposed to you get woken up at 2:30 a.m. because a job has failed. And then sometimes the job is just you move a file out the way, start the job again. You
Yeah,
know, no one's going to thank you for that.
Today, it was my fault as well.
So
yeah,
are you saying, Andrew, that this is competitive advantage, like competitive business advantage for players?
Oh, huge. But and often when we talk about, you know, Flink and Spark and stuff, you know, people talk about analytics, but actually just regular business processing uses these processing tools as well. And doing things like risk calculations can be key to business processing. Often for banks, they need to know where the risk positions are, so they know how much they need to hedge overnight. So the faster you know your risk positions, the better. So doing it in the streaming and knowing it live has a big financial impact for the banks.
And also, is it true that I know, Martin, one of your slides, you had the case for streaming and ML, and you had offline as batch and online as streaming. Are you seeing many machine learning use cases with Flink?
Yeah, but especially more building infrastructure for machine learning. So all these people are usually just building their internal machine learning platforms, like what I said about Criteo, and I think Weibo as well. So I wouldn't say that Flink is much used for machine learning itself, more to build infrastructure for machine learning. But this is something that I think will change now that PyFlink exists, because you can actually integrate with the whole Pandas ecosystem. And yeah, you can potentially do, I mean, I did a demo a couple of weeks ago doing natural language processing with PyFlink. So I think PyFlink kind of opens a lot more possibilities there. Definitely, yeah.
Mm-hmm.
And I guess talking about the horizon, Nick, of like if we start a company, this is where it's at. Yeah, I really think there's a severe lack of tools out there for sort of doing real-time processing at scale with ML. There's not many tools out there where you can drop in a bunch of files or a bunch of videos or have events arriving and have a cluster automatically spawned up to actually classify those things and spit out results. There's a lot of frameworks out there that give you a REST endpoint, and then you have to build and call it yourself. But there's nothing, not that much that's sitting in the stream view of the world for ML.
Yeah, interesting. Well, we have to have another conversation on that, Dan. We haven't sort of much touched on the people and skill side, and I'm keen to maybe to touch on that before we close. I guess here it's the barriers in terms of the skills barrier or skills gap, and making sure that part of the toolkit is knowledge of streaming. Maybe we could just touch on that in terms of organizational use of streaming and the gap that currently would exist in terms of skills.
We kind of discussed that in the very beginning, right? That when I think it was Dan, he asked about like how would this translate to actually adopting stream processing or streaming at an organizational level. But do you have like a more specific question?
I just wonder how do we make the case for the layperson or the organization to actually gain these to gain these skills, and potentially what the barriers within organization for for not adopting it. How do we get up the learning curve quickly?
Well, Nick, if I answer part of the question, I think the tech's meeting the skills in some way. So when streaming first came around, everyone was trying to scurry to learn how to build storm networks, and you had to plug the bolts together yourself, and that was quite a lot of hassle. It wasn't easy to do. Now you've got Apache Spark, and that's got Spark SQL, and you've got Kafka, and that's got KSQL, and you've got Flink, and that's got, guess what, Flink SQL. There's a bit of a pattern forming here. They're definitely trying to move from these clever frameworks to the users, and actually SQL really matches it quite nicely. That kind of path, I guess set theory way of thinking about it is quite nice, and it kind of leads quite nicely to functional programming, where you apply function to function to function, and you're basically reducing the set as you go. It matches really nicely. So I think the stream processing engines and messaging systems are coming to the users, and they're coming to the users by making it easier to program. And SQL.
So you're saying that they're coming towards the users because they're putting it into a language that they're already familiar with.
Exactly. And you still need to understand what's going on under the hood, because like Marta says, you've got to understand what's going on if you're processing things in event time, not arrival time, and you're getting late events and missing stuff. So an implication is you could miss events if you miss a window, but as long as you know what's going on, it's a huge jump towards the user, I think.
Yeah. And so Dan, I mean, you've been banging this drum for a while. What do you see is now the difference between the responses you used to get and the response you get now?
I think I should have stayed in this area. Now's the time where I could have made some money, I think. I think it's a very different reception to what I used to get. So I think my first conference talk on this sort of talk was 5 or 6 years ago, and at the time it was just a room full of people. Maybe it was just a terrible talk, but all just looked at me blankly, and at the end of it, they were like, it's big data tech, it's completely useless. Whereas now, like, you're sort of preaching to people that have already got a Kafka in their stack, and it's just like they're one step closer, right? It's like, oh, we'll just hook it up to that.
Kafka, Trojan horse that's sort of opened it up.
And I think Andrew's point is really good. How it's changed. Back 6-7 years ago, you had to learn something completely new to do this, and also like sort of streaming. It's very functional, as Andrew was alluding to. And I think the world's changed over the past few years. Obviously, the streaming tech's moved to using SQL, which is the language most people are familiar with, especially if they're doing batch jobs. It's their bread and butter. But also, we've got a bunch of programmers now that are way more familiar with functional. There's a lot of people that are in Clojure, Haskell, even the latest versions of Java are very functional. So it's very easy to make that transition to use streaming. And I think we're getting there now. Now the SQL's in. Like, I was just thinking about this with Hadoop the other day, about where that started out, you know, managing like deployments and having to manage all the nodes out there and things falling over and restarting them, and all the configuration was an absolute nightmare. And now effectively it's not quite a MapReduce job, but if I want to run a MapReduce job now, like I'm using a lot of AWS Athena these days, and I just like, I've got like tens of terabytes in a data warehouse, and I just write an SQL query and it automatically runs that job on a cluster. I don't have to worry about all the infrastructure there. And that seems to be where streaming's going now. We'll get to the point in the next few years, hopefully, where we don't even have to worry about the tuning or how the cluster's spinning up. We are literally just writing SQL in a console window, for better or worse, depending if you like that or not.
Mm. Yeah, so there's a lot of, but will belie the power that that you've got at your fingertips, because it's all behind the scenes. So finally, Marta, maybe you just like to say, if people want to get further involved with the Flink community, presumably you're able to be a contributor and to actually submit code into the Flink repository. Could you maybe say a little bit about that?
Yeah, sure. I mean, on the Flink website, you can find all the information to contribute. Like, the contribution process is pretty well explicit. And yeah, I always kind of like to emphasize that you can contribute code, but you also can contribute documentation, which, yeah, sometimes is also important. And yeah, there's a lot of, what?
Sorry, how many contributors are there on Apache Flink?
I don't think I can precise overall, but like every release, the last release we got like 300 contributors. So like from the past 3 or 4 releases, it's just been consistently over 200 people contributing to Flink. I mean, overall the number of course is higher, but per release the maximum we have were 300 people. Yeah, but yeah, so the process is pretty straightforward. If you want to contribute code, you usually just open a Jira ticket in the project, and the maintainer will get back to you, or you just ask a maintainer to assign you something and you can work on it. Yeah, so usually also, yeah, there are just also a lot of other different ways that you can contribute. So if you're using Flink and you just find a bug and you report that, it's already a great contribution. So.
Okay.
Or if you correct a typo in the website, that's a contribution too. So
great.
You don't need to rewrite Flink or something like that to actually contribute.
Okay, well, I think we're just running out of time. We might have to leave it there. So thanks, Andrew. Thanks, Danny. Thanks, Marta, for really interesting discussion. Just to let people know that if you want to catch up on any of the videos, we do have all the videos up on the Bristech website, so brist.tech/videos. We actually do have another event happening next week. We have James Hughes from NextJump talking about the egoless tech culture, which should be really interesting. We also have Martin Hogg from Oracle on the panel. And so many thanks to our sponsors for 2021. So GoCo Group, Oracle, Cloud Infrastructure, Storm, and Over Energy. Obviously, they make it happen. So many thanks to them, and many thanks to you, Marta, for regaling us about Flink tonight. And will you be sharing your contact details if people have other follow-up questions, and presumably be sharing the slides as well? I'll send those around afterwards.
Yeah, for sure. And yeah, you can just reach out to me on Twitter or on LinkedIn, something like that. Okay, amazing. Well, thank you, Marta, and thanks to our panel, and we'll hopefully see you next week. Thank you. Goodbye. Thanks. Bye, everyone.